All right, we're going to do a little recording here to review this chapter 4, and I'm going to kind of walk you through the review on page 342, but here's just the main topics. So first of all, we have to start with, let me get the pen here, start with knowing the quadrants. So here's 0, pi over 2, pi, 3 pi over 2, and then back to 2 pi. So if you have to draw an angle in standard position by quadrants, you just have to know what quadrant it's in. So if they wanted you to draw 15 pi over 4, okay, we know that it repeats every 2 pi. This would be 3 3/4 pi. So we go around 2, 3, and another 3/4. So this would be that angle right there, and there's the terminal side, and here's your initial side. And this always goes up to the x-axis. So, and then if you go negative direction, this is negative pi over 2, negative pi, negative 3 pi over 2. Notice that these are 2 pi apart, and this would be negative 2 pi. So if you did negative 5 pi over 6 and had to draw that, you'd start here, and then negative 5, 6 would put you like this direction, and that would be then in quadrant 3. So you got quadrant 1, 2, 3, and then quadrant 4. So we should know how to do those. All right, the next thing is coterminal angles. If you're given an angle like pi over 3 and you want to find an angle coterminal, you add or subtract multiples of 2 pi. If you're in degrees, pi over 3 would then be 60 degrees, and you're going to plus or minus 360. Now if I put an n here, it's because I can add 2 times 2 pi, 4 pi, and so on. So if you have to come up with one positive and one negative. Now, to do 2 fractions, you're going to make this 6/3. So pi over 3 plus 6 pi over 3 gives me 7 pi over 3. If I take pi over 3 and subtract 6 pi over 3, I get negative 5 pi over 3. Again, pi over 3, negative 5 pi over 3, and 5 pi over 3 would all be in the same spot on the unit circle. Okay, that would be going around once, that's 2 1/3 right there. Negative 5/3 would go back this way, and then pi over 3 would just be that one. Here you just add multiples of 360, so you'd have 420 and negative 300. Again, those are the same degrees as the radians up there. All right, next thing. How do you convert from degrees to radians? So let's suppose I had 120 degrees. I want to convert it to radians, so I multiply by pi over 180, and this is 120 over 180, which simplifies to 2/3. So this becomes 2 pi over 3. If you have, let's say, 5 pi over 6, and you want to convert that from radians to degrees, then you multiply by 180 over pi. These cancel. This goes in there, and you get 150 degrees. So those are your rules for going from degrees to radians and radians to degrees. Now, if they give you something like, let's say, convert 3, that's radians because there's no degree, and you want to convert that, then you got to multiply by 180 over pi, and you're just going to get 540 divided by pi on the calculator, and then you're just going to get a decimal. So again, this 3 radians, that would be something like this picture right there. So then whatever you get, if you want to do this in degrees, whatever 540 divided by that is. So again, I think that those conversion rules either multiply by pi over 180 or 180 over pi to convert back and forth. Okay, degrees, minutes, seconds, 2 degree decimals. If I have 26 degrees, 32 minutes, 45 seconds, and I want to do degrees, divide by 60. Beginning, put the outside one right here. So 45 divided by 60 on the calculator is what going to be 3/4. So So that's 0.75. So now I have 26 degrees, and then I do 32.75 minutes. And then I grab the calculator from there, and I keep the whole part. And now 32.75 divided by 60 is going to be 0.5458. Now again, I think this makes sense. 32 minutes is a little more than half, and a little bit more than half as a decimal would be a little bit bigger than 0.5, so my answer seems right. Okay, then when you want to go from degrees decimal to degrees minutes seconds, so let's say I had 47.385 degrees. Now I multiply by 60. And I take 0.385 times 60. And I get 23.1. So I keep this, and now I have, sorry, let me erase that. 47 degrees, and now I have 23.1. So now I'm going to keep the 47, keep the 23, and now I'm going to take 0.1 times 60. 0.1 times 60, and round it to the nearest one, that's going to be 6 seconds. Okay? So again, divide by 60 when you're going from degrees minutes seconds to degree decimal, and then multiply by 60 when you're going from this to degrees minutes seconds. Okay, the next topic is we get into the circular motion problems. We define radian measure to be theta, and this is S and this is R, and radian measure is defined to be S over R. Okay, so 1 radian would be where this length is exactly the same as this length, and you'd get 1 radian. Now, to find arc length, you're going to take this formula and take this times this. So this has to be in radians. So if you had a problem and it said that the radius was 6 inches and the angle was 120 degrees, you'd have to convert this to 2 pi over 3 before you found S. So now I have 6 inches times 2 pi over 3. Now notice the units is going to be inches, so this is going to end up being 4 pi inches. Now, if this was already in radians, then you just multiply it out. So finding the length of an arc, it's just R times theta, but theta has to be in radians. All right, to find the area of a sector, which would be like this shaded region, here's your S and here's your R. Your formula is A area equals 1/2 R squared theta. And again, this has to be in radians. So what if my radius was 6 inches, and let's say theta this time was pi over 4. So I just go here 1/2 R squared, 6 inches squared, and then theta pi over 4. So you just have the 36, that'd be 18 divided by 4, 9/2, so I get 9 pi over 2 inches squared, and then I just go to the calculator. So again, 36 on the top. Okay, and then you got 2 times 8 on the bottom, right? So 36 over 16 reduces to 9/2, but you still also have the pi here. So area of a sector, 1/2 R squared theta. I'll do a circular motion problem here in just a bit. The next things are just finding points on the unit circle. So you guys got to know how to fill in your unit circle. At pi over 6, you have root 3 over 2, 1/2. So then up here at pi over 3, you have 1/2 comma root 3 over 2. At pi over 4, it's root 2 over 2 comma root 2 over 2. Now here it's going to be 2 pi over 3, 3 pi over 4, 5 pi over 6, negative positive, 7 pi over 6, 5 pi over 4, 4 pi over 3, 5 pi over 3, 7 pi over 4, 11 pi over 6. Now again, these line up, these line up, these line up. You got the same ordered pairs this way, and I think these are going to be opposites of each other. So this would be negative root 3 over 2, comma, negative 1/2 here at 7 pi over 6, and you guys can be able to do that. So then on the test, if it says, what arc length has an ordered pair of this? You'd go to quadrant 2 and say, hey, that's at 3 pi over 4. Now, if they wanted the cosine of 11 pi over 6, now we go to this one. We know that ordered pair is root 3 negative 1/2. So the cosine of 11 pi over 6 is going to be positive root 3 over 2 because that's the x value. If they wanted you to find the sine of negative 3 pi over 4, now we got to know that that's right here. That ordered pair is negative root 2 over 2, negative root 2 over 2, and the sine is the second one. So this is negative root 2 over 2. So you just got to practice that thing. Now, I'll probably do the circular motion problem on the next video, but to finish this off, the things that are coterminal, so if they ask for the sine of, let's say, negative 17 pi over 6, how are you going to do that using the period as an aid and not use your calculator? So this as a mixed number is negative, what, 2 and 5/6 pi. So I think about there's negative 2 and 5/6. That puts me right there. And that pi over 6 ordered pair right there in that quadrant is negative root 3 over 2, comma, negative 1/2. And because it's sine, the answer is going to be right there. Okay? So you just got to find the quadrant. Now, reference angles, always acute, always positive. So the acute angle for this is that angle up there. The reference angle would be pi over 6. So if I wanted to use reference angle to do this, I could find the sine of pi over 6, which I know is 1/2. Now my answer is either going to be 1/2 or it's going to be the opposite, negative 1/2, depending on the quadrant. Well, sine in quadrant 3 is negative, and that's why I have to go with that. So reference angle, what if they said 246 degrees? Well, 246 degrees, okay, there's 180. It's going to be someplace down here. I need to know that. Well, from here to here is 180. So if I take 246 minus 180, there's my reference angle, 66 degrees. Let's do a couple more. Reference angle. Let's do a negative 117 degrees. Okay, negative 117 is going to be like right there. I draw this up. Well, from here to here would be 180. So if I take 180, subtract 117, this angle right here is 63. And that's the reference angle. Always positive, always acute. Okay, then the last thing on this, anytime you're given a trig function, let's say you're given sine theta equals 2/3 and you're in quadrant 2. They want you to find the tangent. So we're going to draw pictures. Every time we're given a trig function, we're going to draw a picture. We just got to know where to draw it. So a reference triangle in quadrant 2 is going to look like this. Now you drop this down to the x-axis. Here's your theta, always from the positive side of the x-axis. Okay, so sine is opposite over hypotenuse. So to find this side right here, 9 subtract 4, this is going to be root 5. All right, so now find the tangent. The tangent would be 2 over root 5, opposite over adjacent. Quadrant 2, I have to remember to put the negative. This answer I could probably rewrite as negative 2 root 5 over 5 to get the best answer. What if they asked you for the cosecant? Well, cosecant's reciprocal, so we just simply get 3/2. do another one. What if they told you that a point stopped at 5, -4, and they wanted you to find the tangent of that angle? Then let's say you also had to find the cosecant of that angle. All right, so how do I draw 5, -4? That's where the terminal side goes through. So that's this thing right here is my theta, but I draw this up, and this is the 5, and this is the -4. So the tangent of this is going to be -4/5. Y over X is tangent. Now, 25 plus 16, this is going to be root 41. So the cosecant of this, we're in quadrant 4, so that's negative, so it's going to get negative root 41 over 5. Now, over 4, because we have this over the opposite. So this is, root 41 is positive, but the -4, that's going down, so it's negative. So this would be my answer for the cosecant. The secant of theta here would be root 41 over the adjacent side 5, and it's positive because cosine and secant are positive in quadrant 4. All of these things, when you're given one trig function, draw the picture. Cosecant of theta equals root 29 over 6. No, that's not right. Let's do it over 3. Okay, so I draw the picture. I don't know where to draw it. I put it in quadrant 1. Cosecant would look like that. Okay, so this is 29 subtract 9. This is root 20, which should also be written as 2 root 5. Now, I have my triangle. I can find anything I want. What if they wanted the cotangent? 2 root 5 over 3. Done. Adjacent over opposite. All right, I'm going to stop the recording here, and then we're also going to look at circular motion problems and do the rest of this in the next review.